So when antigens, the proteins found on the viruses or bacteria, are in the cell membrane, then because viruses tend to infect cells, then we're going to activate the cytotoxic T cells or the natural killer cells. Now remember, they are both lymphocytes, but this is specific defenses. They form receptors that help them specifically identify one invader. Natural killer cells, on the other hand, are non-specific defenses. They are looking for the difference in cells that seem abnormal. So when we're looking at this natural killer cell, notice we have an abnormal cell. It's not checking for a specific antigen. It's just looking to see something's wrong with that cell, so I need to kill that cell. On the other hand, when our cytotoxic T cells are checking cells, they are checking for a specific antigen that they have been cloned for due to the presentation from a macrophage of that antigen. So they are looking for something specific, therefore they're specific defenses. Now the other thing is, notice that the T cells actually clone into an army. Natural killer cells, they don't clone into an army. You have a certain number of those and they run around your body patrolling, doing this thing that we called immunological surveillance. So you don't get a cloning of those, you just get a certain amount. And of course, I'm sure you were making some every day, but we're never cloning an army of them in the same way that we are cloning an army. Here we're clonal expansion, we're cloning an army of cytotoxic T cells. So they are both used to kill cells that are infected with their viruses, but one is just looking for abnormalities, the other is looking for specific markers called antigens. But what do they both do? Well, they both basically kill the cell basically in the same way. Now, viruses can also be engulfed by our antigen-presenting cells, the macrophages or the dendritic cells. They will then go find the helper T cell that recognizes it. That helper T cell will actually help activate the cytotoxic T cells and also will always activate the activation of the B cells. So notice activation of, we have antigen presentation, helper T cell, activation of B cells, What do B cells do? They produce plasma cells, and what do plasma cells do? They release antibodies, and in this case, the antibodies will attach to these, again, attracting complement proteins. They will actually neutralize these, prevent them from being able to infect the cells, and they will also make it easier for phagocytic cells to engulf them. But remember, these are much smaller than these. So whereas antibodies do a tremendous job against these, killing the cells that infect these do a tremendous job against these. Antibiotics, which we take as medicines, do nothing against these. They only help against bacteria. Let's look at some different categories, and there might be some slightly different names used, but basically the categories will always be the same. So when we talk about immunity, the first thing is we have what we call innate immunity or acquired immunity. Innate means that, we are genetically already determined that we're immune to certain things. There are certain animals that can have certain diseases that we can never have, or we may have certain diseases that other animals may never have. There may be certain things that would infect plants that would not infect us. So if we already have a genetically determined immunity, then we call that innate. Now, acquired immunity then is what we're going to need to be able to develop against exposure to different things. So acquired immunity falls under two categories, active or passive. Now, if something is an active immunity, what that means is that we need to produce our own antibodies against whatever that is, against the antigen, against the invader. If we have a passive immunity, that means that we are able to receive antibodies from somebody else. Remember I told you we can receive antibodies, but we can't receive T cells. So if we produce our own antibodies, then we have active immunity. If we receive antibodies from somebody else, then we call it passive immunity. Now, under active immunity, we have what we call either naturally acquired active immunity or induced active immunity. Now, naturally acquired active immunity would be the whole process we described where we get infected by something, we activate our B cells produce plasma B cells, and the plasma B cells then basically, because we were exposed to the infection, we produce our own antibodies, and then we do that again because we are exposed to the antigens, the things that make us sick. Now, induced active immunity basically means this is what happens when we get a vaccine. When you get your flu shot, we don't give you the real flu, but what we do is we inject the antigens, the shapes of the proteins that would be found on those actual infections. And when they get in our system, our body thinks it's the real thing. So it goes through the response of making antibodies against it. Therefore, if we ever do get the real thing, then we already have the antibodies in our system that help us become activated against whatever the infection would be. So naturally acquired means we actually get the sickness and we develop our antibodies to it. Induced active means that we get a vaccine that causes our body to make the antibodies because it thinks we're infected. Now, passive, again, we're not making the antibodies, we are receiving them. So the two ways we do that is naturally acquired. Our mom gives us this in two ways. One thing is when we are actually, before we're born, and we are connected to her by our placenta. Even though our blood never mixes, we can diffuse products of the blood across the placenta into our body to protect us until we can form our own. And then the other thing is breast milk also, after we're born, breast milk also takes mom's antibodies and transfers it into us. That's why a lot of times you'll hear that babies that are breastfed are healthier than babies that are only formula fed. Okay, now, so that's naturally acquired passive because we got it from mom. Now remember, all this is getting it from somebody else. But this induced passive immunity is when we receive antibodies from somebody else. And this is often the case in situations, we call them immunoglobulins, or gamma globulins even. So this is, say, if somebody made a snake venom antibody, and then they gave us the antibody to help fight the venom of the snake if we were bit. So again, we are receiving the antibodies that have been prepared and taken from somebody else or something else and given to us, usually through some sort of injection. Whereas here we're receiving it from our mother, either across the placenta or in breast milk. Now again, these were passive because we didn't make these antibodies, we received them from somebody else. This is active because whether we were exposed to the actual sickness and made it, or whether we were given a vaccine and we were only given the antigen shapes and our body thought it had it, so it made it, both of these we make our own antibodies. Okay, well that finishes up our topic on immunity, and there's a lot more to it, but I hope at least you've learned some.